All right, guys. So as you worked through those first 6 problems, my hope is that maybe you noticed a bit of a difference between whether the order that you gave the answers in mattered or not. So for example, on number 1, 2, 4, and 5, the order mattered. So for example, let's look at number 4. When you're talking about a passcode, we all know that if the passcode to your iPad is 2357 and you type in 7532, it's not going to unlock your iPad. The order that you type in those numbers makes a difference. The order matters. However, if we jump ahead and look at number 6, in that one, the order does not matter. If I am calling a pizza place, let's say I'm ordering Pizza Hut, and I want to order a pineapple and pepperoni pizza because that's my favorite, and if you haven't had it, you're missing out. If I want a pineapple and pepperoni pizza, if I call Pizza Hut and order a pineapple and pepperoni, or I call and order a pepperoni and pineapple, I'm going to get the same pizza no matter what. It does not matter what order I give them the toppings in. Or let's take another pair of toppings. If I get mushroom and pepperoni, that would be the same pizza as if I order pepperoni and mushroom. The order that I say those toppings in does not matter. When we talk about counting methods and how many ways there are to count something, like in the examples on 1 through 6, we obviously eventually want to develop some shortcuts, right? Hopefully, those you were able to figure out relatively easily, and maybe in the 10 minutes you didn't finish all of them or get an answer to all of them. That's okay. But you probably can tell that these numbers are going to get really big really fast. For example, these we're looking at like 4 things or 3 things, and we could have situations, and if you looked at any future problems, that have a lot more things that we're counting, and so we need some shortcuts here. We don't want to have to list out the different ways every time, and I'm going to help you with some of those shortcuts. Before we can use the shortcuts, we need to determine if a problem is what we call a permutation or a combination. Now, let's dive into what those words mean, okay? A permutation is situations where the order matters. In the problems that you just did, number 1, 2, 4, and 5 would all be permutations. The order makes a difference. When you're typing in a passcode, the order matters. When you're arranging a wall, what goes on walls, the order matters. A combination is problems where the order does not matter. In the problems that you just did, number 3 and number 6 would be combinations. The order does not matter. Number 3 was talking about groups of songs. So if you played song 1, 2, 3 or 3, 2, 1, that's the same group of songs. The order doesn't matter. And we already talked about the pizza topping one. Okay, so all we're going to focus on today is looking at a problem and telling if it is a permutation or a combination, because that's the first step to solving these problems. Okay, let's dive into some. A survey asks people to rank comedy, drama, action, and science fiction according to how much they enjoy watching each type of movie. How many possible responses are there? Well, there's a key word in this problem, and that is rank. When you're ranking something, the order matters. It matters what I put first, second, third, fourth, and so this would be a permutation. I don't need to figure out how many different rankings there are, how many possible responses there are. It just tells me to tell whether it's a permutation or combination. This is a permutation. The order matters because I am ranking them. B, a literary magazine editor must choose 5 short stories for this month's issue from 30 submissions. How many different groups of 5 short stories can the editor choose? All right, well, the key phrase here is how many different groups. This is a combination because the order does not matter. He's not ranking the short stories. He's not putting them in any sort of order. He's just making groups of 5 stories from the 30. So it doesn't matter if he says his group is story 1, 2, 3, 4, 5, or if he says his group is stories 5, 4, 3, 2, 1. That's still the same group of stories. So the order does not matter, and so this is a combination. Why don't you pause the video real quick, try to read C and D, and see if you can determine which is which, and then press play. All right, C says that there are 30 dogs in a dog show. Blue ribbons are awarded to the top 3 dogs. How many different groups of dogs can receive blue ribbons? If you said that this is a combination, you are correct. And what makes this a combination is that it's asking for the top 3 dogs and you're looking at the groups of dogs. Now, if this problem had said there are 30 dogs in a dog show and blue ribbons are given to first, second, and third place, that would make it a permutation because it matters if I get first or if I get third. The order matters. But in this one, it's just giving a blue ribbon to the top 3 dogs. So it's not ranking those dogs. It's just making a group of 3. So it's a combination. Now we can contrast that with D that says there are 30 runners in a cross-country race. How many different groups of runners can finish first, second, and third? This is a permutation. The order matters. I care if I get first or if I get third. That would be a difference, and so the order matters there. All right, so the key is that a permutation, the order matters, and a combination, the order does not matter. So what you are going to do now is go back to that how many ways worksheet. And for the entire worksheet, all 24 problems, you are going to read the problem and label it as a permutation or a combination. You do not need to solve it. You don't need to answer how many different ways there are. We'll get to that. All you have to do is label it a permutation if you think the order matters, and a combination if you think in that problem the order does not matter. All right, have a great day.